Hello students, we had started our discussion on alkaloids. In this session, we'll be continuing with the alkaloids. Okay, we'll be discussing the constitution and synthesis of choline. Okay, now choline is an example of piperidine alkaloid. Its molecular formula is C8H17N is the molecular formula. C8H17N is the molecular formula of choline. Its structural formula is NH CH2 CH2 CH3. This is its structural formula. It is an example of piperidine alkaloid. Choline is one of the simple alkaloid and principal toxic substance present in seeds and other parts of spotted hemlock, a shrub that grows in wet locations. The extract of hemlock containing choline was used as an official state poison by Greeks. Okay. Choline was first alkaloid to be synthesized by Ladenburg in 1886. How it is generally isolated is what we are going to discuss now. Choline is isolated from the powdered hemlock seeds by distilling with caustic soda solution. Okay, we distill the hemlock seeds, powdered hemlock seeds with caustic soda solution. Caustic soda is NaOH. The distillate contains choline, which is extracted with ether. It is separated by using ether. The ether is then evaporated when the alkaloid is left behind as an oily residue. So what is done is hemlock seeds are taken. It is treated with caustic soda, NaOH, and it is distilled. When it is distilled, you get a mixture containing choline. Okay, so this alkaloid is extracted by using ether. It is extracted by eating ether. So when it is shaken with ether, the alkaloid comes into the ether, and then ether is evaporated. You get the choline. Now let us discuss the constitution or the structural elucidation of choline. Let's discuss the constitution. From the analytical data and molecular weight determination, the molecular formula of choline is found to be C8H17N. H17N. Okay, this is the molecular formula that has been found by the molecular weight determination. This is the first one. Second, now how the structure was elucidated is what we are doing. When this choline, that is C8H17N, is treated with zinc, zinc, it gives C8H11N. It is loss of hydrogen takes place, -3H2. This is conarine. This molecule on oxidation with permanganate gives this molecule, that is pyridine 2 carboxylic acid is obtained. Pyridine 2 carboxylic acid is obtained. See, we are trying to find the structure of this. We don't know the what is the structure of this molecule, that is the alkaloid. So when this alkaloid is treated with zinc, it gives quinine, which on oxidation gives 2-pyridine carboxylic acid. So this reaction shows few facts. I mean, from this we can confirm few facts. One is, in quinine, a pyridine nucleus is present with a side chain. That is, in quinine, because this on oxidation gives pyridine with carboxylic acid, means this molecule should contain a pyridine nucleus. This molecule should contain a pyridine nucleus with a side chain. This molecule should contain, because if there is no pyridine here, pyridine will not come in. So this on oxidation gives this molecule. That means this molecule also should contain a pyridine ring, and there should be a side chain. See, oxidation, the side chain may have been oxidized to an acid. Okay, so this should contain a pyridine as well as a side chain. This is one thing. See, and then quinine having pyridine nucleus. Quinine molecule having pyridine nucleus. So this has a pyridine nucleus with a side chain, right? Now, quinine having a pyridine nucleus is formed when quinine, I mean this molecule loses, three three H2 molecules, that are 6 hydrogen atoms. So by loss of hydrogen, this molecule is present. That means by loss of hydrogen, a double bond is formed. So thus it can be confirmed that this quinine has a pipyridine nucleus with a side chain. It has a pipyridine nucleus with a side chain at second position. Let us see what is that side chain later. See, I repeat. This molecule on distillation gives you this. This on oxidation gives you this. So you get a pyridine nucleus. Okay, pyridine carboxylic acid is what you are getting. Now, you are getting product as a pyridine carboxylic acid, means this quinine should also contain pyridine. So this is the first thing. But this is formed by loss of hydrogen. This means this should contain pipyridine, because if hydrogens are removed, then only you get this. See, if I remove two hydrogen and two hydrogen, then only you are going to get this. That means this contains this nucleus, is what they want to say. Okay, now, since the molecular formula of quinine is C8H17N and pipyridine, and the pipyridine is quinine is, and the pipyridine is C8H17N, and pipyridine is C5H10N. That means the side chain, getting this, the side chain should contain C3H7. We're getting this. See, this formula is C8H7. This formula is C5H10. What is remaining? H7. So that should be as a side chain. Okay, I repeat. This on distillation, zinc, when treated with zinc, gives this molecule. This on oxidation gives you this molecule. So on oxidation, you are getting a pyridine, means this molecule also should contain a pyridine nucleus. This is the first thing, with a side chain at second position. Why only second position? Because it has been oxidized to acid here. So this is formed by dehydrogen, removal of hydrogen. That means if pyridine is formed by dehydrogenation of this. So that means this should contain a pipyridine nucleus. Okay. The formula of this is, pipyridine formula is this. That means the difference should be the side chain. So this is what you mean. Right. Now, next one. Now the question is, how this side chain is arranged. I mean, whether it is normal, or whether it is branched. That is what they have to find out. The side chain, that is C3H7 in choline molecule can be represented in two ways, that is CH2 CH2 CH3, or like this CH CH3 CH3. That is, it may be normal N propyl or it may be isopropyl branched. It may be N propyl or it may be isopropyl. So hence there are two possible structure of this choline molecule. That means it can be, we know that now it has a pyridine nucleus, so it may be CH2 CH2 CH3, or it may be like this. CH3. Okay, now so we want to confirm whether the structure is this or this, because there are two possible structures now. On heating, choline molecule, that is C8H17N with HI in presence of red phosphorus hydroiodic acid, choline undergoes reduction to give you this molecule. You get N octane, 1 2 3 4 5 6 7 8 N octane. Okay, now this confirms that the structure of choline, this is this only. This only. Why? Because if this would have been the structure, then we would have obtained a branched chain here. See, we are getting an N octane, that means normal octane. That means this side chain also should be N propyne only. If this was this, you would have got this product. It is CH3 CH3 is what you would have got. Okay, we have got a branching here. We didn't get a branched product here. Why? Because this is not branched. That means, I mean, this side chain is straight chain, side chain is not branched. If the side chain also branched, the product would have been branched. So we got a straight chain here as a product when on reduction. That means this also should contain a straight chain. Okay. Further, an additional evidence for the above structure was afforded by exhaustive methylation. Hope you know what is exhaustive methylation. In the last session only we had discussed it. We're taking pyridine as an example. Exhaustive methylation of an alkaloid which gives an alkene. Exhaustive methylation gives an alkene, conylene, C8H14, with the elimination of NCH3 thrice. Okay, the conylene can be reduced to form N octane. So exhaustive methylation is another evidence that suggests that this is the structure of choline. Okay, now, so this was further confirmed by the synthesis by Ladenburg. Ladenburg synthesized this. This was further confirmed by the synthesis. That is the Ladenburg synthesis. Ladenburg synthesis. The structure of was further confirmed by Ladenburg synthesis. In Ladenburg synthesis, we start with this. Okay, N methyl. We start with this. N methyl pyridinium iodide. We start with N methyl pyridinium iodide. Okay, N methyl pyridinium iodide is what we use. Okay, I minus. N-methyl pyridinium iodide, CH3I. This N, it will be CH3 N methyl, N plus, this will be minus. When this is heated, 570 Kelvin, this is N methyl pyridinium iodide. Okay, when this is heated, you get this molecule, CH3, 2 picoline. This molecule, this molecule, when treated with acetaldehyde, that is CH3CHO, in presence of ZnCl2, undergoes loss of water, H2O, resulting in the formation of this. CH, this molecule, to propene pyridine. So we start with this molecule, that is N-methyl pyridinium iodide. When it is heated, that is methyl shift share. We get 2 picoline. When it is treated with acetaldehyde, loss of water, H2O takes place. So you get CH double bond CH, CH3. When this is treated with sodium over ethanol, okay, when it is treated with this, it undergoes reduction to give this double bond gets reduced to single bond. You get CH2, CH2, CH3. So you get the molecule. Okay, so this is the preparation of, the synthesis of quinine by Ladenburg. So this is how the structure of quinine was formulated. Along with that, the synthesis. Okay, it was confirmed by synthesis. Thank you.